Hello everyone, welcome back to our channel. Let's discuss the next named reaction, that is Cope elimination. So this reaction is an example of elimination reaction. Already we know that we have three types of elimination: alpha elimination, beta elimination and gamma elimination. Three types of elimination we have. Alpha elimination means, see this example. We have chloroform. If you use the base initially, what happens? The H will be removed in the form of H plus, thereby you will get C minus. In the latter step, Cl is removed in the form of Cl minus. Thereby what happens? Already minus charge is there, we are giving the positive charge. The minus and positive can be neutralized and we are coming up with carbene intermediate. Okay, so from the same carbon we have removed hydrogen and Cl. The removal of an atom or group from the same carbon is commonly called as alpha elimination. Next, beta elimination means, see this example. With respect to Cl, this is alpha carbon, this is beta carbon. Hydrogen is going to removed from the beta carbon and Cl is going to removed from the alpha carbon. If you remove HCl, what happens? We will get pi bond here or not? We will come up with alkenes. Beta elimination produces alkenes. Okay. In case of gamma elimination, see this one. With respect to Cl, this is alpha carbon, beta carbon, gamma carbon. If you remove hydrogen from gamma carbon, Cl from alpha carbon, what will happen? HCl will be removed or not? Thereby, a bond formed between these two carbons or not? We will come up with cyclic compounds. So gamma elimination produces cyclic compounds. So we are very clear. Alpha elimination produces carbenes, beta elimination produces alkenes, gamma elimination produces cyclic compounds. Okay, let's see the statement of Cope elimination. Thermal elimination of N oxides to olefins and N hydroxyl amines. So here the reactants are N oxides. The products are olefins and N hydroxyl amines. This is an example of elimination reaction or not? The elimination reaction may be alpha, beta or gamma. Here the Cope elimination is the example of beta elimination. Remember that. Why? Because the products are olefins. Already we know that in case of the beta elimination, the products will be olefins only. Then what are the reactants here? N oxides. In generally, N oxides directly not available, readily not available. Always these N oxides prepared by using the amines, tertiary amines in general. So if you see the equation, see this one, it is a tertiary amine or not? Nitrogen connected to three different groups. Okay, so this is tertiary amine. Tertiary amine is subjected to oxidation by using a peracid, metachloroperbenzoic acid. Otherwise we can use peroxide also, H2O2, hydrogen peroxides. So hydrogen peroxide or any kind of the peracid can convert the tertiary amine into the corresponding N oxide. See this one. N nitrogen donating its lone pair electrons to the oxygen. Here this is the nascent oxygen generated. It is producing N plus O minus. These are the reactants in the Cope elimination. Okay. Here what happens? See this. With respect to nitrogen, this is alpha carbon, this one is beta carbon. Beta carbon is having hydrogen or not? From the beta carbon, hydrogen will be removed. From the alpha carbon, this nitrogen moiety will be removed. Thereby what happens? We will come up with a pi bond here or not? So that product is olefin or not? See, that is the olefin. Whatever the H is removed from the beta, H removed in the form of H plus or not? The H plus move towards this O minus. So it will become OH or not? That's why this is NOH R dash R dash. Nitrogen attached to OH, that's why N hydroxyl amine. In this way, we can convert N oxides into the corresponding olefins and N hydroxyl amines. If you see the mechanism, this mechanism is the example of the concerted mechanism. This is not the ionic mechanism. That means we cannot observe any kind of the ions, carbocations, carbene ions, free radicals. Okay, we cannot observe any kind of intermediates. We will observe the transition state. That is also cyclic transition states. That's why this is an example of concerted mechanism. Here see what happens. Already we know that from the beta carbon hydrogen is removing, from the alpha carbon nitrogen is removing, right? If you see this one, these single bonding electrons moving towards nitrogen means we are giving minus charge to the nitrogen or not. Already plus charge is available, the minus and plus will be neutralized or not. Okay, so this is going to be represented in the cyclic transition state. See this, we know that CH bond is cleaving or breaking, that's why dotted lines. The hydrogen is approaches to O minus or not, that's why there is a formation of OH bond or not. So dotted lines between oxygen and hydrogen. Here in between the nitrogen and oxygen there is no change, but the alpha carbon and nitrogen is going to be cleavage or not, that's why dotted lines. In between the alpha and beta carbon there is a formation of pi bond or not, that's why dotted pi bond. So in this way we have created 5-membered cyclic transition state that is subjected to the decomposition like this. Thereby we will come up with the corresponding olefin and the N-hydroxyl amine. Okay, now the people are saying this elimination is an example of syn elimination. Syn elimination means the atoms or the groups which are removing from the carbon atoms, those should be present on the same site. In case of the stereochemistry, we will observe the products. Okay, as far as the stereochemistry is concerned, the atoms or groups may be present in either in the above the plane or the below the plane. If you want to do the Cope elimination, both the atoms or groups either present in above the plane or below the plane, then only we will get the product. Okay, let's see some of the applications. See this one, this is the tertiary amine or not. The tertiary amine treated with peracid means you will come up with corresponding oxide or not. N oxide. In this N oxide we have a beta hydrogen. So beta hydrogen and this one removed to produce the corresponding olefin and the N hydroxyl amine. Here also similar situation. From beta hydrogen is removed, simple pi bond is formed and okay. Here also similar kind. This is the tertiary nitrogen. Tertiary nitrogen is treated with metachloroperbenzoic acid. Oxidation phenomena takes place, so it will take oxygen and produces the corresponding N oxide. The N oxide having the beta carbon and beta hydrogen is available. That's why simply pi bond formation takes place here. Pi bond formation takes place. Okay, see this example. We are discussing that it is an example of syn elimination. Here it is the possibility. See this. This tertiary amine in which the nitrogen is above the plane or not. Keep in your mind. Metachloroperbenzoic acid means we are doing oxidation or not. Right? So this tertiary amine is converted into the corresponding N oxide or not. Corresponding N oxide is formed. Now see the feasibility. Here you have one alpha hydrogen and 2 beta hydrogens. Okay. At the beta hydrogen we need hydrogen atom or not. If you see this beta carbon in which the hydrogen is above the plane or not. But here hydrogen is below the plane. But your N oxide is above the plane or not. That's why we can remove this hydrogen, not this hydrogen. That's why the product will be the formation of pi bond is here only, not here. Now you can understand the concept of syn elimination. The last example in which this is tertiary amine. Tertiary amine subjected to oxidation by using the metachloroperbenzoic acid produces the corresponding N oxide. The N oxide having the beta hydrogen, the pi bond formation takes place like this. So in this way we can do the Cope elimination. Okay, thank you very much.